As part of trigonometry, we're going to be looking at solving quadratic trigonometric equations. Okay. Now, if we look at this first question, so we've got 5 sine squared x plus 3 sine x minus 2 equals 0, and we've got our interval, our range of between 0 and 360. Now, we've looked at some questions that look a little bit like this earlier on in the year, obviously not with trigonometry in there. Okay, but what we should hopefully spot straight away is this looks vaguely like a quadratic. Okay, it's just rather than using x's and y's, I'm using sine x instead. So what I'm going to do, the same as what we did earlier on, is I'm going to use a substitution. So instead, what I'm going to say is I'm going to say that y equals sine x, and I'm going to substitute that in. So this will now become 5y squared, because I've got sine squared x, plus 3y minus 2 equals 0. Okay, right, we're now into a normal quadratic form, so I can solve the equation however you want to solve it. Remember, if you solve using your quadratic solver on your calculators, you have got to show using the quadratic formula as well, otherwise you will be losing marks. Okay, so if I solve it through factorising, I end up with 5y minus 2 and y plus 1 equals 0. So I can have my two solutions of y equaling 2/5 and y equaling minus 1. However, we aren't interested in y, we're interested in x. So I have to come back to my original substitution. So rather than y, I'm going to substitute back in the opposite way. X equaling to x equaling to 2/5. And I'll have sine x equaling minus 1. Okay, so I can find my first solution. So I just solve these simple trigonometric equations. So sine x equals 2/5, so x sine to the minus 1 both sides. So I'll have x equaling 23.6. And do the same on this side, sine to the minus 1, and we'll get x equaling minus 90. Now remember, guys, these are just our principal values. Okay, we need to find all values that work. So I need to go back to my trigonometric graph. So I've got my sine graph. So if we focus on this side first, I know my original solution is in here at 23.6. So I've got to find my second solution. I know that with sine, my other solution comes from doing 180 minus x. So I'll do 180 minus that. So my second solution should be 156.4 degrees. Right, now we've got a slight issue with this one. Okay, in the fact that my first answer is down here at minus 90. Now minus 90 isn't actually within my range, but I can use that to find another value that might be within my range. Okay, because if I'm going between 0 and 360, I'm going to have another value in here that is going to be within my range. Okay, now I know that sine repeats every 360 degrees. Okay, that's the repetition. So therefore, this value in here must be 270 degrees. Okay, so I've got 4 solutions. However, I know minus 90 is not a valid solution. Okay, because it lies without my range. I use it to find my other one, but that itself lies without my range. So my 3 solutions I should get are 23.6, 156.4, and 270. So we're starting to combine different parts of our knowledge now. Okay, right, just have a look at another one. So this time we've got solve tan squared theta equals 4. Okay, and we're solving again between 0 and 360. So it looks a little bit like a quadratic again. I'm going to make my substitution. So I'm going to say y equals tan theta. So I'm left with y squared equals 4. And I can solve y equals 2. However, this is the big tripping point, and something that people often forget. When I square root, I don't just get one answer. I get two answers. Okay, you've got to be so careful. So I can have 2 or minus 2. But again, I'm after values for theta or for x. So I'm going to have to go back through again. So I'm going to say instead, tan theta equals 2. And tan theta equals minus 2. And I need to solve. So, first one, if tan theta equals 2, then theta will be 63.4. And if tan theta equals minus 2, I get theta equaling minus 63.4. Again, we've got to find all of our values in our range between 0 and 360. So we've got to think about our tan graph now. Okay, slightly more difficult. We've got to be really careful on what it looks like. Again, make sure we remember where our asymptotes lie. So we've got an asymptote at 90. We've got a crossing point at 180. Got an asymptote at 270. And then we move up to 360. Okay, so between 0 and 360, my first one in here somewhere at 63.4. So I'm going to repeat here again. Okay, repetition for tan is going to repeat 180 degrees this time rather than 360. So I'm going to add on my 180. So I will get a second answer at 243.4. Now, same as with the last one, minus 63.4 does not fall within my range currently. So minus 63.4, because we're going to have the other asymptote along there at minus 90, my other solution, my minus 63.4, is going to sit somewhere in here. So between 0 and 360, I'm actually going to have two other solutions. We know it repeats every 180 degrees, so I'm just going to add 180 on twice. So I can get 116.6 and I can get 296.6. And I've got my different values. Again, remember, we discard the minus 63.4. We use it to find our other solutions, but that does not sit within our range. So this time we have got 4 solutions. We've got a solution at 63.4, solution at 243.4, solution at 116.6, and a solution at 296.6. Okay, right. Last one I want to show you before you have this one. Okay, now we'll just move. So, last one I want to show you. So, solve 2 cos squared plus 9 sine x equals 3 sine squared x. Now, the first thing we should notice, hopefully, is the fact that we've got 2 different trig ratios within. Okay, so this is where we're going to have to refer back to our trigonometric identities that we did at the start of the topic. Okay, because I cannot solve if I've got 2 different trig ratios involved. Now, if I look, I've got 1 representative of cos in cos squared and 2 of sine. So it's going to make far more sense to get it all in terms of sine first. So, the identity we would need to remember is the fact that cos squared x plus sine squared x will always equal 1. So if I want to change cos squared for sine squared, this is going to become 2 lots of 1 minus sine squared x plus 9 sine x equals 3 sine squared x. I can expand my brackets out. 2 minus 2 sine squared x plus 9 sine x equals 3 sine squared x. And we'll get everything onto one side and then we can look at solving. So, manoeuvring everything to one side, I will get 0 equaling 5 sine squared x minus 9 sine x minus 2, and that's going to equal 0. Now we're in exactly the same situation as we have been for the last couple of examples. Okay, I've got something that looks a lot like a quadratic, just in terms of sine x instead. So I will do y equals sine x, and then I'll substitute that in. So I'll have 0 equals 5y squared minus 9y minus 2. Solve however you want to. Again, make sure you are showing evidence of how you are solved. So we're going to factorise to 5y plus 1 and y minus 2. So my two solutions, I'll have y equals minus a fifth and y equals 2. Okay. We're not interested in y, we're interested in values of x. Now our range this time is between minus 180 and 180, so we're going to have to be a bit more careful with that to make sure we get within our required range. Okay, so I'm going to go to sine x equaling minus a fifth and sine x equals 2. So first of all, we'll find our principal values, so I'll do the inverse sine of both parts. So if I inverse sine minus a fifth, I get x equaling minus 11.5 degrees. If I try and do inverse sine of 2, I do not get an answer. Okay, so that doesn't exist. Now, as soon as the principal value doesn't exist, I can ignore that altogether. Okay, that's never going to give me a solution. So I've only got to focus on one side. Now I'm looking at between minus 180 and 180. So if I think about my sine graph, sometimes it's easier to do the whole one on one side, and we'll go back the other way. Now between minus 180 and 180, I am looking at between those points there. Okay, I've got a first value down here at minus 11.5 degrees. Now, the only other place where I'm going to get anything along the lines of minus a fifth is in here. Okay. Now I know this repeats. Okay, the repeat is worth 180 minus x. So that means this one here is going to be minus 180. Add on my add on 11.5. So my other solution should be minus 168.5 degrees. Nowhere else is that going to work. So this time I've only got the two solutions, minus 168.5 and minus 11.5. Okay, because sine x equaling 2, x cannot exist. Okay, you've got to be really, really careful that you check what your region is that you are working between, what your interval is. Okay, right, two for you to have a go at now. So what I want you to do is pause the video. Okay, two on there for you to have a go at. Okay, one nice simple one, another one that's broken down into more steps to make it a bit easier for you. Okay, so have a go at those two for me, and then we will go through them. Okay guys, so let's have a look. So first one shouldn't cause too many problems, hopefully. So we're all in terms of cos x straight away. So it looks very much like a quadratic already. All I need to do is make my substitution. So we'll go y equals cos x, and then we can substitute it in. So we'll have 2y squared minus plus 9y plus 4 equals 0. Then I can solve my first equation. Okay, so if I can solve this equation, I'm going to go to factorising. So I'll have 2y, what have we got, 8, so 1 and 8, plus 8y plus 1y plus 4 equals 0. And we will get to 2y lots of y plus 4 plus 1 lot of y plus 4, 0. So we'll end up with 2y plus 1 and y plus 4. So my two values I'll have at y equaling minus a half, and I'll have one at y equal minus 4. We're interested in x's not y's, so I can substitute that back in. So I can have cos x equals minus a half, okay, or I can have cos x equaling minus 4. Find the principal values first, so I can inverse cos both sides. So when I inverse cos the First one, cos to the minus 1 of minus a half will give me 120. If I try and inverse cos minus 4, I do not get a solution. So when I go x, that doesn't exist. Always worth putting that in so that you're showing your understanding. So that can be disregarded. So the only one I'm interested in is cos x equals minus a half. So just got to think about our repeated value. We're only working between 0 and 360. So we think about cos. First value in here at minus 120. We know we repeat at 360 minus x. So 360 minus my 120, my second value should be at 240. And they will be my two solutions. Okay, right, the second one. Potentially a little bit harder. Thankfully, it has broken it down for us. Okay, so first part. 5 sine x equals 1 plus 2 cos squared x. So we need to show it can be written as 2 sine squared x plus 5 sine x minus 3. So I'm getting rid of my cos squared in this case. So using my identities, I can rewrite this as 5 sine x equals 1 plus 2 lots of 1 minus sine squared x. I can expand out. 5 sine x equals 1 plus 2 minus 2 sine squared x. And then if I just manoeuvre everything to one side, 2 sine squared x plus 5 sine x minus 3 equals 0. And we solved the first part. Second bit, now we've got to solve it between 0 and 360. Okay, so in the form of a rough quadratic, so I know that my substitution is going to be y equals sine x. So I will have 2y squared plus 5y minus 3 equals 0. So I can solve through that I want to. Okay. Again, I will solve through factorising just because I find it slightly easier. So it's going to be 2y minus 1 and y plus 3 equals 0. So I'm going to have a solution at y equals half and y equals minus 3. We will reverse our substitution again. So we will have sine x equals half and sine x equals minus 3. We can find our principal values. So I'm going to inverse sine both sides. So I can have x equals 30 degrees here. And when I try and do this one, doesn't exist. Therefore, I can disregard those solutions. Okay. Find all values between 0 and 360. Think about what sine looks like between 0 and 360. I've got my first solution in here at 30. So my second solution is here. I repeat for sine at 180 minus x. So I'll take 180 away. And my second solution is 150. Okay, and they will be my two solutions. Please make sure you check what your range is between, because sometimes they will be different. Okay, make sure you've marked them, make sure you have an understanding of what you're doing. Then if you can refer back to show my homework and see what questions need to be completed off 10F, please.